Okay, we're going to look at this parallel to serial converter, and it's this small little black guy here. There's a couple that look very similar. Make sure you use the correct one. Also, make sure that you have it oriented correctly on your board and it's not upside down. Otherwise, the wiring is going to get all screwed up and whatnot. So just make sure you're using the right one in the right orientation. Lots of wiring again. The whole idea behind this is I can actually power 8 LEDs, and rather than using 8 pins, I can just power them off of 3 different pins. So this is just a way of expanding my outputs on my Arduino, so I don't have to eat up all of my pins. I can use this converter to add more pins. So lots of wiring. I'm not going to go through it all, but you can see these are all 220 ohm resistors, LEDs, and you can see all of these come into the converter here. So these pins are the ones that are actually running this guy here. And then it gets power and ground from the board. And then this guy gets grounded and powered, and basically you use pins 9, 11, and 12 to actually run all of 8 of those outputs. Okay, so the code basically looks like this. This is just basically setting up some variables. This is like our delay variable. These are setting all of my pins, which include the data pin, the latch, and the clock pin. I'm not super comfortable about exactly how this thing works, but hopefully you'll be able to look at the code and kind of piece through how you can make this work. This is basically a variable. Byte variable means it's made up of 8 bits. So, and we're going to use this to control each of the 8 different LEDs. They're each going to be set to a different byte, and I'll show you how to do that in just a second. We'll come back to this. This is kind of like a written code that we're going to keep referencing. Okay, this is our setup that we're very used to. Okay, this is just defining the pins. That would be pins 9, 11, and 12 for my latch, my data, and my clock on that. Okay. And then, again, I'll come back to the update shift register when we talk about the main loop that we've got here. So the first thing we're going to do is, again, set that LED variable to 0, which basically turns all of the LEDs off, at which point it goes into this, it calls this update shift register function, which is this guy up here. Okay? And this basically, first thing it does is, again, it makes everything low on the latch. Okay, then what I do is, this is a shift out function, and you can kind of read a little bit about it here, but basically it sends in, you know, what my data pin is, what my clock pin is, and then what LED I'm at. Okay, so again, remember LEDs, this is a byte variable that's going to be made up between 0 and 8, actually 0 and 7, excuse me. As we go through. Once it sets that LED there, then it basically turns that pin high, which is essentially what we've got here. So it basically calls that register starting with LED to 0. So actually nothing is going to be on initially. Actually, I guess just the first one will be on initially. It'll wait that delay, which I think is 1/10 of a second. And then basically I'm going to go through a for loop where essentially I'm going to go from 0 to 8, okay, stepping through, shifting that LEDs one each time. And that's what this bit set is, because again, this is a byte variable, okay? So each time it goes through, it's going to shift to the next bit, again, between 0 and 7. So it starts at 0, then 1, 2, 3, and it'll shift those variables. Then recall that function where now, rather than just have that first LED on, it'll have the second LED on, then the third LED, fourth LED, till it gets to the end. Okay, then this for loop ends, and it starts back over here and shifts LEDs back down to 0 and starts the process over again. Okay, so when you see this, we'll plug this guy in here. Okay, and you'll see, and you can see how every 1/10 of a second it adds another LED, goes back to the beginning, and starts the process over. Kind of clears things out and goes again. Okay, so again, the whole idea behind this is I can use just 3 pins on the board to run 8 pins of LEDs.